Alright, Pre-Calc 11, this is Mr. McPhee here. It's been a while since I've done a video with the Easter in there and everything going on, so I hope you're having a good day. Here we go. It's time to rock and roll with some a new topic. We're done radicals in the sense of things. Now we're on to trigonometry. Trigonometry is one of my favorites. So today we're going to look at review of what you did in Math 10. So that's good news in a sense. So for those that enjoyed trig, we're getting back at it. For those that struggled with trig in grade 10, this is your chance to possibly pull up your socks and understand it better than you did in grade 10. So here we go. So here's an overview of what Pre-Calc 11 trig is about. So trigonometry basically is a study of angles, and then that specifically gets into triangles. In grade 10, you did right triangles, and we're going to talk about those today, and there'll be a practice sheet that goes with it, with the right triangle practice that you did in grade 10. Then your Pre-Calc 11, so this is your grade 10. Pre-Calc 11 will then focus on non-right angle triangles, so triangles that don't have a 90 degree in them, and some abstract trig, like for example for angles that have that are bigger than 90 degrees or bigger than 180 even, something that doesn't even make sense from a triangle point of view. So that's kind of where we'll be going in Pre-Calc 11. Today's lesson is on this. So as a reminder, just a few things about naming triangles. I just want to make sure you're aware of some things that might be helpful or possibly confusing. And if you don't know how to name angles and sides in a triangle, trig can be very difficult because you won't know what you're even doing. So let's say you had this triangle that had the corners, vertices labeled big T, big B, big H, so uppercase, they use those. So you could call this like triangle TBH, or you could call it triangle THB or triangle BHT. You could do any combination really of those BTH letters. To be honest, get that one, there's a good pun. To be honest, it doesn't really matter the order that you put that in. So angles. If someone wanted to describe a certain angle in this particular triangle, you could just say, well, angle B, which you can see is 90 degrees. You could also reference it as angle TBH, and I think of it like following a road map. If they said TBH, angle TBH is TBH. If you follow that, it's the kind of the middle letter, in this case B. So again, I agree, angle B is way quicker. If someone said find angle B, there it is. This is another way to reference it. You could also reference it as angle HBT, same thing. So those will be the same. So angle T, which is pretty obvious, it's right here, could also be called angle BTH. Or I guess you could call it angle HTB. Angle HTB. Right, so that's how they might disclose how to find an angle. They might write it this way or that way. Sides, they might say, okay, to find this side length here, they might call it BH. They might write a line above it for a line segment, or they just might write BH, which is pretty obvious. Okay, I'm finding that length. You could also call that this big angle T right here. If you go across from it, this also is called little t. This side is called little t. So if you were to ask to find BT, this length here, you could also refer to that as it's across from this angle. That could be little h. And HT here could also be referenced as across from that angle is little b. So those are just the ways that the questions might be asked, and if you know what they're asking, then at least you can jump into the trig. If you don't know what they're asking, then you're handcuffed. So let's go through 5 examples of things you would have done in grade 10 in regards to finding sides and angles, and we'll talk about what's going on here. So basically there are 3 things, in my opinion, 5 things really, but 3 things that it boils down to when it comes to trig in grade 10. If you are given a question like this, let me hide all the other ones so it doesn't look overwhelming. So let's say they give you a right angle triangle and they want you to find little q. So here's the picture. They've given you the picture. Little q, first of all, is where? It's across from big Q. So this is little q. That's what they're wanting. When it comes to trig in grade 10, there's really only 3 things you need to remember. One is Pythagoras. That can be helpful when you have 2 sides and you want a third side. There's the 180-degree rule in a triangle where all the angles add up to 180 degrees. And then there is something you learnt in grade 10, SOHCAHTOA, which is your sine, cosine, and tan, which we'll get back to remind you of that. So those are the 3 things you really need. So when I look at a question like this, I'm like, what do I need? Do I need all of those? Do I need one of them? When I see something that wants a side and I have 2 sides given, I know right away that's Pythagoras. How I know the 180 rule is out because, well, I'm not even finding angles, so it's out. SOHCAHTOA is kind of a mixture. It's for when you want to find sides and angles if you have a mixture of both. But here I have all sides. This is Pythagoras. So I'd write out my Pythagoras rule. C squared equals A squared plus B squared. Remembering C is always the hypotenuse. The hypotenuse is always across from the 90 degrees. So in this case, the 10 is my C side, even though it is little r, but in this case, we're calling it C for the Pythagoras formula. And then the other 2 sides are my A and my B. So if you want a reminder of your little picture here, C is always the hypotenuse, A and B are the other 2 legs of the triangle. So in this case, 10 is the hypotenuse, A and B, doesn't matter which one I make A. I'll make the Q here the A and the 4B the B. And then to solve this, something you did since grade 8, is I would square this, that's 100, square this, that's 16, subtract the 16 over to the other side, and you'd end up with 84 equals Q squared. And then at that point, remember to get your answer, you would then square root 84. And what do we end up with? So I'm just double check, make sure I haven't made a goofy error. So there's my 84. Then I will square root 84. And the length is, and I'll just round to 1 decimal place today, so 9.2 units centimeters. And then I would always think about it. Does that answer make sense? Does this length here, should it be less than 10? Well, the hypotenuse of a right angle triangle is always the longest, so it makes sense that it is less than 10. Okay? So that's a Pythagoras review. Then comes number 2. So there's good old Pythagoras. Then comes a question like this. And again, you got to take time to digest what do they want. So they've given you a triangle with triangle ABM. There's a 90 degrees. There's a 13 degrees. Angle ABM. What does that even mean? Okay, so it's an angle ABM. They want this right there. That's what the question is asking. So again, a right angle triangle, I ask myself, Pythagoras, 180 rule, or SOHCAHTOA. Pythagoras is definitely out in this case because I'm not finding any sides. Is the 180 rule enough? Well, 180 rule is if I have 2 angles, which I have, I can always find the third. And I know that these have to add up to 180. So I take 180 degree rule, subtract 90, subtract 13. And that will give me angle B. So 180 degrees minus 90 minus 13. So 180 minus 90 is 90. 90 take away 13. Take away 10 would be 80. Take away 3 more would be 77 degrees. And then I would just, personally, I would just double check, does that even make sense? If that's 77, 13 plus the 90, that better give me 180, otherwise I'm going home. Okay, and we're good to go. All right, next question is the fun part with SOHCAHTOA. Now, here's 5 little examples we'll go through. Now remember what SOHCAHTOA stands for. SOHCAHTOA. So sine, which is abbreviated SIN, and O is opposite, divided by H, which is hypotenuse. So that's sine, that's this guy. This one, remember, the C stands for cosine, which your calculator abbreviates cos, and that is A, which is adjacent, divided by hypotenuse. I'm just going to write hype. So there's your sine, there's your cos, and then the TOA is tan, or tangent, which they abbreviate tan, and that's your opposite, OPP, over adjacent, ADJ. So we'll talk about how to go through that and make sure your calculator's in the right mode. So here we go. So here's the question. Another little question again. And I've given 3 examples here because you're only in SOHCAHTOA, you're only going to see these 3 situations ever. So again, here's your picture. Right angle triangle. Got an angle and a side, and I guess a second angle of 90 degrees always. Little q. Okay, where's little q? Across from big Q. There's what they want. So when I'm looking at this, I always go to my plan. Is Pythagoras helpful? Well, I only have one side. Pythagoras is out. 180 rule? That would be great if I was to find this angle here, but I don't want that angle, so it's out because I'm finding a side. So it has to be SOHCAHTOA as my only help. So I pull out my little SOHCAHTOA rule. SOHCAHTOA. How I determine whether it's sine, cos, or tan, I go to my angle that they've given me, not the 90. The 90 just tells me I can use SOHCAHTOA. So I sit at the angle. So there's where I'm going to sit. And I label my sides. That is so important that I label things. So I always label hypotenuse first. The hypotenuse is across from the 90. This side is the hypotenuse. The side that's across from the angle that I'm sitting at, this angle, this side here, this is the opposite. And the third side then by default has to be this one, which is the adjacent. Now out of that, I don't know what to use yet. So what I do is I look at, what do I want? I want this, so I must keep my opposite working. And then I look at this side here, adjacent. I don't want it, and I don't have it. So it's useless to me. So then what comes out to play? What uses opposite and hypotenuse? Ding, 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 sine. And how I do the setup, and this is so important, I write sine, and then I put the angle beside it. So sine of 40 degrees equals opposite over hypotenuse, and the opposite side in this case is Q, and the hypotenuse is 14. And then when you have the variable on top, this is when in grade 10 you would have learned to cross multiply or to multiply by the common denominator, or you might have put this over an imaginary 1 and then went Q is equal to 14 times sine 40 divided by 1. And there's your answer, but now you need to go to your calculator, and this is important. Make sure your calculator is in degree mode, has a dig or a D. If it's not in dig or D mode, you should search in your calculator for a DRG button of some sort. It's either going to be a button itself, or it might be in a funny little spot where it's highlighted. You might have to press a second button or a shift button. So make sure it's in degree mode. If it's not, you would press this. Because right now, if I had it in the wrong mode, if I have it in rad mode or R mode, radian mode, it'll give me the wrong answer. So I need to make sure it's in degree mode. If you happen to have a graphing calculator, then where it will be is under mode. And then make sure when you go down to it with your little arrow keys, make sure the degree is highlighted. If the radians is highlighted, oops, like this, then right now it's in radian mode. I want it in degree mode. So when I go and type this in, I'm typing in 14 times sine 40. So 14 times sine 40. Enter. And my answer is 8.999, or rounded, that'd be 9.0. 9.0, and the units, meters. And I would just double check, does that make sense? If this is 14, which is the hypotenuse, this side should definitely be smaller, and it's drawn not exactly to scale, but that looks like it could be 9. It makes sense to me. Okay, next example. Find angle B. So here's angle B, which they're also calling theta. They might use, that's a Greek letter, means an unknown angle. So they could use theta, they could use angle B, they could even call it angle QBL. So again, I would look at this. Pythagoras is out because I don't want this side. 180-degree rule is out because I don't want the angle. So then I would label the sides. Sitting at the angle, I would then label the sides. So this side would be the opposite. This side would be the hypotenuse. And this side would then be the adjacent. I would then look at the picture and say what I want this. So I don't care about these two. I don't care about this side. I want the adjacent and hypotenuse being involved. So this has to be then, according to SOHCAHTOA, A and H uses cosine. So cosine of the angle, and I can either put theta or B. I'll put theta. And then I would end up with putting adjacent, which is 12, over hypotenuse, which is 15. And when you have the missing angle here, you're then going to, one step that you have to use with your calculator is when you're finding the angle, you will always use the second button on your calculator. So then you will go inverse cos, which you did in grade 10, so you'd go second cos, and you'd get cos with a little -1 button, and then 12 divided by 15 in this case. And it comes up to be 36.86 or 36.9 degrees. 36.9 degrees or 37 degrees for that purpose. Okay, last little example, then we're done. What I'm going to do in this question, I'm going to change one thing because I think otherwise it's going to be similar to the other one. I'm going to make this here 7 centimeters. So I'm just changing the question to make it work out. I just saw it now. Last question. They want side QM. QM is 7. Oh, that would be an easy question, wouldn't it? Now, if that was the question, that'd be awesome. If QM, it said find QM, I would answer 7, be done. So I'm going to change this question now because I just changed the numbers here. I'm going to change it to side MN. So I'm going to say I don't know what this side is here. I'm going to call this side unknown. Okay, 180-degree rule, out because I don't want that angle. Pythagoras, out because I don't want to find a side with two sides given. I have to use SOHCAHTOA, label the sides. This side is hypotenuse, across from the 90. This side is the opposite, across from the angle given. And the side that I'm wanting here is the adjacent. Again, I look at what do I want? I want this. What side do I not care about and don't have? Hypotenuse, you're out. So what uses O and A? O, that's tangent. So then I go to my tangent setup. Tangent of the angle, which is 20 degrees, of opposite 7 over adjacent, and I'll call this side whatever I want. I would call it X or Q. Let's call it Q because it is little q. And remember, when the variable is on the denominator, that's a divide situation. Q is going to equal 7 divided by tan 20. Literally, these just switch places. And you go to your calculator, and you go 7 divided by tan 20. And you get 19.2. And the units are centimeters. So there's the quick breakdown of what's going to happen with any kind of grade 10 trig question. It's either Pythagoras, 180-degree rule, or it's a SOHCAHTOA setup of variable on the top multiply, angle is inverse of the sine, cos, or tan, and the variable on the bottom will be a divide. And those are the 5 things you'll ever see in grade 10 trig. All right, have a good day. Talk to you later. Don't forget to get triggy with it.